Okay, let's look at expansions and contractions. Expansions and contractions do exactly what you'd expect. They either stretch the plane out or compress it, and you can do it independently in the horizontal and in the vertical dimensions. And these are the matrices you'd use for that. So a horizontal, you just put a K up there, and if you think about what happens here, when you multiply this times xy, what you get is kx and then y. So that's going to be a horizontal stretch or shrink, expansion or contraction, depending on whether k is greater or less than 1. Vertical ones work the same way, except for y is the thing that gets multiplied by k. And if you want to do both of them at the same time, you can do this. We could do some examples of this, but I think it's better to maybe play around with it on a computer and just see what's going on. So there are two websites I've got mentioned here. One of them is this top one is a matrix visualizer, which is this thing. So let's play around with this. It's got this keep Austin weird thing here, and down here is a matrix we can apply to it. So if I change this to a 2, it's going to stretch it horizontally too. If I change it to a 20, it stretches it way out. If I change it to something small, it squishes it in. And then down here, this will change the stretch factor for y. And notice the determinant here. The determinant of this matrix, assuming that your two values on the corners are positive, the determinant's always going to be positive. And notice this doesn't it doesn't switch the orientation. And like right here, the original had an area of, what's that? It's 4 by 4, so it's got an area of 16. Changing this to a 1/2 here cuts the area in half. If I change both of them to a half, it cuts the area to a 1/4, and so on. All right. The next thing to talk about is shears, and I'm just going to go ahead and do that on here. If I change this right here to some number that's not 0, say I change it to 1, it shears this thing in the horizontal direction. If I change it to something big, like a 5, or whatever, it just shears it in different directions. Or not different directions, but by different amounts. So that'll give us a shear. And if I put a number down here, this will give us a vertical shear. So it's just taking the plane and just sort of stretching it like that. Interesting thing about shears is a shear doesn't change the area of the thing. So here's the original. If we change this to a 1, the area of this thing is still the same. It's kind of neat to think about, but if we take this, we start out with a square. Now it's a parallelogram, or I guess a rhombus. But no matter what I change this to, the area doesn't change. The determinant of this thing is always going to be 0, always going to be 1. The thing is, here it's short and wide. If I do this to 100, it winds up being, really long, and top to bottom, it's never very much. But anyway, it's kind of neat that that doesn't change the area at all. Let's go back and look at shears. If we just look at the shear matrix right here, if you take this and multiply it by xy, actually I'll do this one because I've got room. What do you get? You wind up, x stays the same, but y becomes kx plus y for the vertical shear. All right. that's a neat website to look at. But I want to show you one more thing. If you're interested in programming, then the rest of this might be interesting to you. If you have no desire to do any computer programming, you can skip the rest of this video. But I want to show you this other thing. This editor at p5js.org. If you follow that link, it'll take you to my collection of sketches, which I've only got one. But if you look at this, this is a sketch written in the JavaScript library P5 that that'll let you put in your own matrices, and you can put in your own drawings and things. Let's see. The way this works is the setup creates a canvas that's 400 by 400. The draw function tells it what to draw every time. So I've got the background set at a gray level of 220. The translate, apply matrix, those just translate moves the origin from up here at the top to the middle. This apply matrix here changes things so that this is the positive x-axis and this is the positive y-axis. And then these two things draw in the axes. And this says draw a blue square in quadrant, I should say quadrant 1. So it draws in this blue square, and then it changes the color. That's what this push says. Everything we do now, we're gonna basically, it leaves everything alone, and it's gonna change some things for future drawings. So it changes the color to red right here, and then apply a matrix to the plane. Well, the matrix here, it's done A, B, C, D like that, and we have to put the numbers in like this. So right now I've got a this ABCD. It's a shear, or not a shear. It's a contraction of a half, and then a contraction of a fourth, and then it draws in. Notice it uses the same rectangle. Let me reload this. It uses the same rectangle command here, but it gives us this smaller rectangle. And you can play around with the different things here. If I change this back to a 1 and a 1, whoops, and I'll tell it to auto refresh, then the red square is right on top of the blue one. But I could go around and change different things here. Like if I change that, it gives me a shear. Let me change it to a less severe shear. Yeah. So you can play around with this and see the different matrices, and I'm sorry, see the different effects of the matrix. Let's say we wanted to apply a reflection. Let's do the reflection across the line y equals 7. Line y equals 7, the matrix we had for that was, I'm scrolling back up here, 0.96, negative 0.96, then 0.28, then 0.28, and then 0.96. So yeah, that red one is reflected across the line y equals 7x. And if I wanted to put the line in y equals 7x, I'd have to think about that for a second to figure out how to do it. Actually, no, it'd be easy. I'm going to come back up here before the matrix is applied. And I'm going to put in a line from 0, 0 to 100, 700. Yeah. So there's the line there. And I guess if I wanted it to go down to the bottom of the screen, I could also make it go from negative 100, negative 700. Yeah, so we're reflecting across that line right there. And if you wanted to, you could come through here and, you could do things where you could automatically generate this matrix and stuff like that. While we're on it, let's see, this p5.js. if you come over here and you look at the reference, it'll tell you how to use these different things. And it'll tell you about different things you can do with the apply matrix to do different things. So anyway, if you're interested in programming, that might be something you want to play around with. If not, don't worry about it. All right, I think that'll do it for this video.